Hey everyone, these advancements have revolutionized how we interact with, explore, and understand the underwater world. From cutting-edge tools that enable deeper and safer dives to sophisticated systems for monitoring marine environments, I'm unveiling 15 incredible underwater technologies. Starting with number 15, Hujin. By now, we've all heard of UAVs, unmanned aerial vehicles, but have you heard of AUVs? The Hujin Superior Autonomous Underwater Vehicle represents the latest advancement in the Hujin family of AUVs, developed by the Norwegian firm Kongsberg Maritime. Unveiled in December of 2018, the Hujin Superior system offers enhanced data collection, positioning, and endurance for a variety of defense applications, including underwater surveys, covert rapid assessments, and mine countermeasures. On top of the defense applications, the advanced AUV is also suitable for a wide range of government and commercial uses such as geographical surveys, hydrography, marine archaeology, and pipeline inspections. It's built on an existing platform. This one features a hydrodynamic shape measuring about 21 feet in length and weighing about 4,800 pounds. It's equipped with a HISAS 1032 dual receiver synthetic aperture sonar, or SAS. The Hujin Superior produces a 3,200-foot swath at 2.5 knots, delivering high-resolution imagery with a resolution of approximately 2 inches by 2 inches. It also provides detailed imagery of the seabed at a depth of 665 feet, which enhances seabed mapping and inspection with 3 operating frequencies: 200 kHz for deep water inspection, 300 kHz for near bottom inspection, and 400 kHz for very high-resolution inspection. Communication systems on board this AUV encompass an ultra-high frequency two-way link radio, Iridium over-the-horizon two-way satellite link, and the Iridium emergency localization beacon, and it's even got Wi-Fi. Number 14, the Ocean Farm 1. The world's population ain't getting any smaller, and sometimes it can feel like there are more people on the planet than it can handle. And while food supplies may not exactly be limited, world hunger persists. By 2030, the world needs to be able to produce 70% more food than what we're working with now, while using fewer resources and leaving behind a minimal footprint. So that's where Ocean Farm 1 comes in. Despite covering 2/3 of the world's surface, only 2% of our food consumption comes from the ocean. So Ocean Farm 1 aims to fix that problem. This massive 220-foot tall, 360-foot diameter facility is the world's first offshore fish farm, looking for a long-term solution to the exploitative world of your typical fish farm. It can operate all on its own without the use of any external fishing vessels, and it's built to operate for a full 25 years and is able to withstand typhoons and earthquakes, all while producing 1.5 million fish a year. But just like a typical fishing vessel, won't Ocean Farm 1 pick up all sorts of trash that float in the ocean? Well, nope, it's not, because the facility's surrounded by a netting that keeps anything that could harm the fish inside away. Ocean Farm 1 is an amazing facility that will hopefully keep humankind fed for the rest of our days. Number 13, the Submarine Sports Car. So if you got $2 million laying around, then why not spend all of it on a brand new sports car and just drive it straight into the ocean? Well, that's what Submarine Sports Car is made for. This thing takes a page straight out of the classic James Bond films and lets you live out your super spy fantasy as long as you bring in the breathing tank and some goggles. While the manufacturer boasts that it's the only car that can exist both on land and underwater and can transform with just the push of a button. The Sub Sports Car has propellers at its rear and 2 water jets at the front that allow the driver to both steer under the waves and breach the surface again. It's a completely zero-emissions vehicle with a 54-kilowatt electric motor under the hood and powered by a total of 6 48-volt lithium-ion battery packs that, after a 4-hour charge, can last for about 18 miles or 3 hours underwater. And of course, the car's interior is both waterproof and totally impervious to both fresh and salt water. There's even an onboard laser-guided sensor that lets the car cruise underwater autonomously, so you can enjoy the scenery. Needless to say, I guess we are kinda living in the future. Number 12, Hublot Exosuit. When it comes to deep-sea exploration, few technologies can spark our imagination the way that the Hublot Exosuit can. This is a $1.2 million piece of gadgetry that represents the pinnacle of engineering excellence. Unlike traditional submarines, the Exosuit is a wearable submarine primarily made of aluminum, equipped with life support systems that allows a diver to stay submerged for extended periods without worrying about oxygen limitations. The exosuit's design emphasizes maintaining surface-level pressure inside the suit, eliminating the need for decompression upon resurfacing. This atmospheric suit is tethered to support a vessel via cable that supplies power and oxygen, enabling a diver to remain underwater for up to 50 hours if needed. The suit's outfitted with advanced communication equipment and a suite of information-gathering gadgets, and the diver can control the suit's limbs through manipulators, and the feet are equipped with propulsion systems for maneuverability and descent. The exosuit's first major dive to a depth of 1,000 feet took place 100 miles off the coast of Rhode Island. The mission was spearheaded by Michael Lombardi, a National Geographic explorer. He likened the experience to wearing a submarine, a process that's involved a considerable trial and error period as he adapts to the restrictive movements required within the suit. Rather than bending his elbows, Lombardi must roll his entire arm through a series of joints to achieve the desired motion. It may not be easy, but it certainly might be worth it. Number 11. MAG HD. Oil and gas is an incredibly straightforward industry, and it certainly isn't going anywhere anytime soon. For better or for worse, but technological advancements are revolutionizing how companies operate, with underwater drones playing a pivotal role. At BP's Thunder Horse oil platform in the U.S. Gulf of Mexico, a dog-sized robot named MAG HD, or just Maggie, uses magnetic tracks to traverse pipes and inspect the subsea infrastructure. Before Maggie, these dangerous inspections were conducted by specialist technicians who rappelled along the platform, a risky and highly paid job. Maggie is a part of a category known as magnetic crawlers. These devices can move across rigs, platforms, and pipelines both above and below water, utilizing ultrasonic testing equipment and high-def cameras. They're priced at around $60,000 each. Now, these crawlers provide a significant safety and efficiency boost. Life on an oil rig is one of the toughest jobs out there, and so BP's goal with something like Maggie is to eliminate the need for human presence in unsafe environments, improving data collection and significantly enhancing everybody's safety. According to Dave Trutch, the technology director in BP's Digital Innovation Organization, drones and crawlers can conduct inspections in about half the time it takes for rope access technicians, while placing fewer workers at risk. Drones can inspect flaring equipment used to burn off dangerous gases without necessitating a complete shutdown, which can last from 5 to 20 days. And while drones and crawlers cannot yet perform physical repairs, they optimize the process by only deploying human workers when absolutely necessary. Number 10. Dash. Unfortunately, conflict is a part of humanity's past, present, and future. But as we evolve, the question becomes, how do we mitigate the damages and keep people out of harm's way? Submarines, especially diesel-electric ones, remain a significant threat due to their affordability, increasing lethality, and reducing acoustic signatures. The Distributed Agile Submarine Hunting Program, or DASH for short, developed by DARPA, aims to detect and track submarines across vast areas of both deep and shallow waters. DASH operates similarly to an underwater satellite capable of functioning at extreme ocean depths. These underwater satellites, or subulites, are designed for stealthy unmanned operations, scanning upwards from the depths to detect the quieter diesel-electric submarines. In January, DARPA awarded contracts to companies like Cortana Corps for the Shallow Water Agile Submarine Hunting, the SWASH program, with focuses on lightweight, small, and low-power surveillance technologies. Once a submarine is detected by DASH, a small autonomous vessel known as an X-ship will be deployed to track the sub. This is part of DARPA's Anti-Submarine Warfare Continuous Trial Unmanned Vessel Program, or the ACTOV. It aims to autonomously detect and track even the most silent diesel-electric subs. Well, to harness the best strategies for countering those subs, DARPA invited the public to participate in a crowdsourcing initiative. Through the free Dangerous Waters Tactics Simulator, gamers could track enemy submarines and contribute their tactics to DARPA. Successful strategies from gamers will be incorporated into the ACTOV software, ensuring it's got the most effective methods for autonomous submarine tracking. This innovative approach combines advanced technology with public engagement in gaming and leverages collective intelligence to tackle submarine threats. Number 9. MIT's Underwater Camera. Lights, camera, action. Scientists estimate that more than 95% of the Earth's oceans remain unexplored, meaning we know less about the deep sea than we do about the far side of the moon or the surface of Mars. Which is kind of insane when you think about it. But one significant barrier to extensive undersea exploration is the high-cost powering underwater cameras, which typically require either a tether to the research vessel or a frequent recharging on a ship. However, researchers at MIT have made a groundbreaking advancement by developing a battery-free wireless underwater camera. This camera is about 100,000 times more energy efficient than existing underwater cameras, capable of taking color photos even in dark environments. This camera is powered entirely by sound. It converts mechanical energy from sound waves traveling through the water into electrical energy, which powers its imaging and communications equipment. This innovation enables the camera to operate autonomously for weeks before retrieval, allowing scientists to explore remote ocean areas for new species, monitor pollution, or observe the health and growth of fish. Sound waves from various sources such as passing ships or marine life cause the transducers to vibrate and produce electrical energy. The camera then stores that harvested energy until enough is accumulated to power its electronics for taking photos and transmitting the data. They also developed a low-power flash using red, green, and blue LEDs. When capturing an image, the camera illuminates the scene sequentially with red, green, and blue LEDs. Although the sensor only captures grayscale images, the reflected colored light is recorded in the images, which can then be combined in post-processing to reconstruct a color photograph. Number 8. The Ocean Cleanup's Interceptor. In the urgent battle against ocean plastic pollution, where approximately 8 million tons of plastic enter our oceans each year, the Ocean Cleanup has emerged as a beacon of innovation and action. Founded by Boyan Slat when he was just 18 years old, the Ocean Cleanup has tirelessly pursued solutions to rid our seas of plastic waste. Originally unveiled in Rotterdam, the Interceptor represents a milestone in environmental tech. This revolutionary catamaran-like device operates by harnessing solar power and utilizes a system to collect plastic debris efficiently. Equipped with lights, sensors, and a solar-powered conveyor belt, it identifies and channels plastic waste towards its collection mechanism. As plastic flows towards the vessel, it's guided onto a conveyor that directs it onto 6 onboard dumpsters located on a separate barge underneath. This streamlined process ensures continuous operation and maximum efficiency. The vessels have proven effective in high-pollution river environments too, such as the Klang River in Malaysia and the Cengkareng Drain in Jakarta, Indonesia. With plans to deploy more interceptors in key rivers worldwide, including Vietnam's Mekong Delta and Santo Domingo in the Dominican Republic, the Ocean Cleanup aims to strategically position these devices in the 1,000 rivers responsible for the majority of ocean plastic pollution. By the end of 2025, their ambitious goal is to have interceptors actively operating in all those critical waterways. Moving on to number 7, backscatter. With the backscatter, researchers have demonstrated the first ultra-low-power underwater networking and communication system capable of transmitting signals for miles. This groundbreaking technique, developed over several years thanks to the brains at MIT, uses about 1/1,000,000th of the power required by existing underwater communication methods. The system employs underwater backscatter to enable low-power communication. Now, this method encodes data in sound waves, reflecting or scattering them back to a receiver. The system's retrodirectivity minimizes signal scattering in unwanted directions, resulting in more efficient and longer-range communication. When tested in river and ocean environments, the retrodirective device demonstrated a communication range over 15 times farther than previous devices. This underwater backscatter communication device uses nodes made from piezoelectric materials, which generate an electric signal when mechanical force is applied. When sound waves hit these nodes, they vibrate and convert mechanical energy into an electric charge. It all may sound nerdy, but it's almost kind of like echolocation. The biggest challenge facing backscatter communication is that the scattered signal travels in all directions, with only a small fraction reaching the source, thus reducing signal strength. To address this, researchers use a Vanada array, a 70-year-old radio device concept. In this array, symmetric pairs of antennas are connected to reflect energy back in the direction it came from. But with enough time, tests, and trials, this backscatter will allow us to hear things in the deepest depths like never before. Number 6. The Nautilus Yacht Submarine. At the 2022 Monaco Yacht Show, Dutch builder U-Boat Works unveiled a design for the Nautilus, a groundbreaking 1,200-ton, 125-foot yacht submarine. This innovative vessel seamlessly transitions between functioning as a yacht and a submersible, offering a new level of yacht life and adventure. Though many today have probably not read it, Jules Verne's 20,000 Leagues Under the Sea continues to permeate our culture. Despite being nearly 200 years old, the novel has a grasp on today's boaters. U-Boat Works, a world leader in small submersibles, has engineered the Nautilus to combine luxury and safety in a fully certified private submersible. Now, the diesel-electric Nautilus has a depth rating of about 600 feet, a surface cruise speed of about 9 knots, and an underwater speed of 4 knots. Once an order's placed, it can be delivered within 30 months. This vessel is designed to be equally functional both above and below the water. When operating as a boat, it offers an expansive sun deck complete with a freshwater pool, bar, and luxurious dining table. Those features are retracted before the vessel submerges. It also includes a pressure-resistant electrical tender, the Aronnax, which is stored under the aft deck and remains outside while diving. The Nautilus's interior features a 530-square-foot dining and lounge area with 4 large circular windows, each nearly 15 feet in diameter. The proposed design includes a master bedroom, 4 staterooms, and sleeping quarters for up to 6 crew members. Clients can also fully customize the interior layout to suit their preferences, and the superyacht sub can remain underwater for up to 4 days. At cruising speed, its underwater endurance is about 6 hours. When not in use, the Nautilus can dock anywhere that can accommodate its 21-foot draft. The whole thing starts at $26 million. Number 5. Hero Blue. In the realm of underwater exploration, where challenges abound and depths conceal the mysteries, Hero Blue emerges as a pioneering force, redefining capabilities of remotely operated vehicles. Hero Blue, short for Hazardous and Extreme Environment Robot for Biomimetic Multi-Locomotion-Based Underwater Expedition, say that 3 times fast, stands out for not only its ambitious name but also for its innovative design and capability. This proof-of-concept robot measures about 31 inches by 23 inches, and unlike traditional ROVs, it's limited by electric thrusters. Central to its prowess are its unique fins, locomotion mechanisms. Traditionally, ROVs rely on electric thrusters that can be hindered by debris or strong currents, and in contrast, it's got 4 multimodal fins and 2 lateral fins crafted from polymer panels and elastomer tendons. Whether swimming like a fish through open waters or navigating complex seabeds by walking or crawling, it adjusts its locomotion method dynamically to suit the environment. Hero Blue's development marks a significant advancement in underwater robotics. Beyond its current remote-controlled capability, the robot's stereoscopic vision holds promise for future autonomous operations. This potential autonomy positions it as a frontrunner in pioneering underwater exploration missions, gathering data and conducting research with precision. As industries and scientific endeavors increasingly turn to the oceans for resources and knowledge, Hero Blue stands poised to revolutionize underwater exploration and maintenance tasks. Number 4. Deep's Underwater Habitats. It seems that so many of today's innovators are looking to colonize other planets, but what if the space we need lies in our world's oceans? Deep, a pioneering research organization, is set to revolutionize exploration by creating an underwater habitat featuring submarines, livable residences, research laboratories, and observatories on the seabed. It's scheduled to open its doors to the public by 2027. This project will leverage modular subsea habitats known as Sentinel, offering a new frontier for marine research and human habitation. To ensure the smooth operation and habitation of the Sentinel, Deep has established an institute to train divers in transporting and maintaining the underwater architecture. These trained divers will play a critical role in deploying modular habitats and guiding their long-term use. Deep is already in discussions with several partners for the first deployments. The initiative is strategically positioned in the UK's southwest, an area rich in marine engineering, diving, hyperbaric, and submersible expertise. The site chosen for development, the former National Diving Academy Centre in Gloucestershire, covers 50 acres and will be pivotal in testing and developing underwater equipment. Deep aims to establish a permanent human presence underwater by 2027. The Tyndendom site will serve as a core part of the regional ecosystem in southwest of England, fostering development exercises for Deep and other organizations. Initially, this technology will allow scientists to live underwater at depths of up to 600 feet for extended periods, enhancing our ability to observe, monitor, and understand the ocean and its species. Number 3. Tidal stream generators. The quest for sustainable and renewable energy sources has led to the exploration of various natural phenomena, including the movement of ocean tides. A really promising technology in this domain is the tidal stream generator, often referred to as a tidal energy converter. These machines capture energy from moving masses of water, primarily tides, and convert it into electricity. Conceptualized during the 1970s oil crisis, tidal stream generators have evolved to become one of the most cost-effective and friendly methods of tidal power generation available. The fundamental principle behind their operation is pretty straightforward. As water flows through the turbine, it causes the blades to rotate, which in turn drives a generator to produce electricity. The significant advantage of using water currents lies in the density of the medium. Water is approximately 800 times denser than air, which means a tidal generator can produce substantial power even at lower flow. Power output from these devices is proportional to the density of the medium and the cube of its velocity, allowing for the water to move at just 1/10 the speed of wind to generate equivalent power. The development and testing of these technologies have been significantly advanced by the establishment of the world's first marine energy test facility in 2003, located in Orkney, Scotland. The European Marine Energy Centre was created to catalyze the wave and tidal energy industry in the UK. Now, the centre has become a global leader. Its grid-connected tidal test site is strategically situated in a narrow channel that concentrates tidal flows between the Atlantic and the North Sea. The advantages of tidal energy are plentiful. One of the primary benefits is its high energy density. Additionally, this energy is highly predictable due to the regular and cyclic nature of tides, as opposed to wind. Tidal turbines also have a minimal visual impact since they're submerged and thus don't alter the landscape or the seascape. Number 2. The Deep Flight Dragon. The Deep Flight Dragon, a revolutionary personal sub, has swiftly captured the imagination of super yacht owners and marine enthusiasts. Developed by Deep Flight, a California-based firm founded in 1996, the Dragon epitomizes the company's vision of marine aviation. One of the most remarkable features of it is its ease of operation. Unlike traditional subs, which typically require a professional pilot, the Dragon can be driven by almost anyone thanks to its patented intuitive controls. In any emergency, the Dragon's structural design ensures that it will naturally float back to the surface, offering an unparalleled level of safety. The Dragon's equipped with their Deep Flight Drive Manager, a sophisticated monitoring control system that manages critical aspects of the dive, including depth control, battery consumption, and oxygen levels. Now, visually, it's as impressive as it is functional. Resembling a Formula One car, it controls its position and depth with 6 propellers. This configuration allows the Dragon to ascend and descend vertically, enhancing its maneuverability. Powered by lithium battery electric propulsion, the Dragon has a range of up to 6 hours and a cruising speed of up to 4 knots and can dive to about 400 feet. It measures about 16 feet in length, 6 feet in width, and about 3.5 feet in height, and it weighs about 4,000 pounds. The design consideration here makes it an ideal accessory for super yachts, a market in which Deep Flight already enjoys a prestigious clientele, including notable figures such as Richard Branson and Tom Perkins. All the features and this enhanced submarine's utility and appeal allows users to capture stunning underwater footage and locate marine life with ease, all for just $1.5 million. Number 1. Nemo's Garden. When envisioning the future of agriculture, one's mind might wander to the idea of cultivating crops on Mars. However, an innovative Italian firm in the diving equipment business sees the next frontier for food production much closer to home, the sea. Nemo's Garden, the world's first underwater cultivation system of terrestrial plants, exemplifies this visionary approach. Situated off the coast of Noli in Italy, this unique farm consists of an array of suspended, transparent, dome-shaped greenhouses known as biospheres anchored to the seabed. With the global population projected to reach approximately 10 billion by 2050, the United Nations estimates that food production must increase by up to 60% to meet that demand. Nemo's Garden presents a novel solution to this impending challenge. The consistent temperature of seawater further creates an optimal environment for plant growth. Utilizing hydroponics, a soil-free technique that employs water-based nutrients, Nemo's Garden mirrors the method used in most indoor vertical farms. Despite their small size, though, each biosphere is about 7 feet in diameter. It can accommodate between 70 to 100 smaller plants. We tested hundreds of different plants ranging from strawberries to tomatoes, beans, and of course, herbs. Gambarini shares. Various studies, including 2020 research project, have indicated that plants grown in Nemo's garden, such as basil, possess higher essential oil concentrations and more antioxidants compared to those grown on land. Other companies worldwide are also exploring underwater farming. Green Wave, a nonprofit in North America, is cultivating seaweed and shellfish on underwater scaffolds, while C6 Energy in Bangalore has developed a mechanized tractor for planting and harvesting seaweed on the ocean floor. As for Nemo's garden, though, future plans include creating a larger biosphere and exploring different locations to test feasibility in different environments. A small-scale version is set to be established in a cold water quarry in Ohio in the United States any day now. Thanks for watching, everyone. I'll see you next time. Thank you to our channel members.